So object-oriented programming. In the world of program, there's three ways to write code. These are sometimes called styles of programming. The three styles are number one, procedural, object-oriented, functional, which is beyond the scope of this course. So up until now, everything we've done has been procedural. When we learned JavaScript, when we are writing a procedural style, and this course so far, we've been pretending that OOP doesn't exist by sticking to writing all of our code in the main code block. So what is procedural style? It's a very simple way of a code in the 1960 and 1970. Just a way to get started coding. And then we use if and then and loops to control the flow of execution. Think of a medical procedure or a police procedure or a phrase standard operating procedure. When we write step by step, line by line, how to perform a task, we are writing an algorithm. To many people, this feels like a natural way to write code. So here you have your example of writing a code. It starts off with a very simple way, just declaring values and just having a simple for loop, and then it just write it onto the console. Okay, so an object-oriented programming, it's just many tiny programs all working together, such as a program throwing out an object. So in the 1970s, computer scientists were dealing with headaches of software becoming larger and more complex and more difficult to write. A programmer named Alan Kay proposed a new way of programming that he coined object-oriented as a way to deal with challenges of writing more complex programs. By the 1980s, object-oriented programming languages had begun to appear, and by the 1990s, OOP had taken over. OOP has dominated programming for more than 30 years. However, in the recent years, a growing backlash has formed against it. In OOP, our code is organized into classes. OOP requires that all of our code is organized into classes. Think of a class like it's a tiny little program all by itself. We create our application by building lots of little classes. So, and then a structure is also another way of building a class. Each class handles just like a little bit of the overall program. By breaking up our program code into many smaller tiny units, our code should be easier to work with. We'll end up with many small chunks of code instead of one massive block of code. So here it just says, hello, I'm a class, and then here this is the class. The class is a blueprint of creating an object. An object is a single instance or a copy of a class blueprint with unique values. Most of the time, before we can use code from a class, we must create an instance of it as an object. So I'm also a blueprint for making an object. It goes to class goes to object, and then here, hello, I am an object. I'm a copy of the class that you can work with. A class contains data and behavior. I am made up of data I can use and behavior or action I can perform. So here data will come in. You just write, integer, string, boolean, and here the behaviors. Do something, add two numbers. Creating a class and defining class data. Let's say we want to create some coffee mugs. Let's try to represent two coffee mugs in our code. We'll describe the color of the cup, the color of the text, and the text says, and the size of the cup in ounces. So here you have your class coffee mug. Private string, color, get, and set. Here, everything here is going to be private, right? So none of these you're able to collect from an outside or external way. My coffee mug class is made of 4 properties. Properties are the data elements of a class. This class has 3 strings and that one integer, and that detail how it looks and how big it is. So when we define variables inside a class, we call them the properties of the class. They're just variables that belong to this class blueprint. Don't worry about the private means just yet, or what get set does. We'll get to those soon. Next, anytime we want to make a copy of this class blueprint with unique details, we call that initiating or instatating, or creating an object in order to create an individual object. We need something called a constructor. A constructor is a special bit of code inside the class that describes how to make it. Here's our constructor code for our coffee mug class. The constructor always shares its name with the class. So if my class is called coffee mug, the constructor will be called coffee mug too. So this right here, this just means that it starts off beginning of the code to get it working. So public coffee mug, string, what color, string. So here you just have whatever your public, you know, um, where you want to set it to. So here you have your color, your text color, your phrase, and your size. So here it takes 4 arguments, 3 strings, and an integer, and assign those values to the new coffee mug. Now, back in our main code block, we can start creating new coffee mugs. The possibilities are endless. Here you can make a different, all these different type of strings. Now we create 2 objects. The objects have a data type of coffee mug. They are the class of coffee mug. They have different properties. They have properties of their color, text phrase, size, and the values are completely different for each instance of a coffee mug objects. These are the 3 key points. A class is a blueprint for creating an object. A class contains data and behavior. An object is a unique copy or instance of a class. To create an object or instantate an object, we use a constructor. However, we aren't done yet. Our class has data that represents it, but has no behavior. It can't do anything. Next, we need to give the coffee mug functionality. So what we can do with these coffee mugs creating functionality, let's decide that we want our coffee mugs to do 2 things. Number 1, fill with coffee. Number 2, drink coffee from them. So, so you just might have a value if you want to, or Boolean if coffee is filled. You might have noticed that up until now we have not talked about functions. If you recall, functions were really important part of JavaScript. We created functions in order to do stuff in our web pages in JavaScript, but in C# we haven't talked about them at all. That's because in C# functions belong to classes. When you write a function and put it in a class, we call it method. Personally, this author doesn't like that we changed the terminology in object-oriented programming. A method is nothing more than a function that exists inside of a class. An OOP function don't exist because they all live as methods inside of a class, so we have this strange terminology shift. Personally, I think them as functions. As far as this author is concerned, this is what the old saying, I have tomato, I say tomato, you say tomato, as a method is a function. The only difference is that it lives inside of a class. You will occasionally even hear people say functional method. So here, people have always asked which operator is used to define the C# function. With respect to object-oriented, the term method is used, not functions. When function is part of a class, it's called method. C# is an OOP language that doesn't have functions that are declared outside of class. That's why all functions in C# are actually methods. Let's write a method to fill the coffee mug with coffee. So here, you're going to start with public void fill. So here it's going to have it public, your void, that means anything cannot be entered 0. So, and you're going to have your fill. So console.writeLine, here you pour coffee into, and you can concatenate this phrase. This method is called fill. It doesn't take any arguments or parameters. It doesn't return any values. Every time it's executed, it prints to let you know that we poured some coffee into our virtual coffee mug. Let's create a second method called drink. This will let us drink our coffee. So here you do your public void drink the same way, and you're just going to concatenate. It tastes great. Let's jump back over to the main code block and try to use our coffee mugs. So here you have your class program, static void main, strings, and args. Coffee mug 1 is equal to the coffee mug. Here you just have your your properties. Again, same on your mug number 2. You have two sets. Mug 1, you're either gonna fill it or you're gonna drink it. So you pour coffee and then you drink some coffee. Our objects are working great. The fill and drink methods are working. However, I can see a problem. It's possible for us to drink coffee from the mugs without ever having filled with coffee. Let's keep improving our virtual coffee mug so that this acts more like a real coffee mug. Improving the behavior of coffee mugs. We'll create a bool that checks if the coffee mug is filled or not. In the constructor, we'll set the values to be false when the coffee mug is created. So here you have your class coffee mug. Again, you have all your private type of properties here. And then here you have your public properties here. Now let's improve fill and drink. So if is full is equal to false. So if it's true in here, then right, you pour coffee. Else, you pour coffee all over the place. This is drink. So if is full is equal to true. If it's false inside here, then you drink some coffee out of plus phrase. If it's true, there's no coffee in there, fill it up first. Finally, let's test a new function of our mugs. Okay, so here you have you have one set: fill, drink, fill, drink. Pour coffee, you drink coffee. There's no coffee, you pour coffee. Coffee spills all over the place, and then you drink some coffee. All right, so our virtual coffee mugs are working great in our very real world. Good job. There's a lot to unpack on this lesson, so let's summarize everything one more time. In OOP program, we create classes. Classes are their own data type. Classes are a blueprint for objects. An object is a single instance or one copy of the class with its own set of values. To create an object, we instantiate. Anyone know how to say this word? Instantiate. There you go. Instantiate it with a class constructor. Classes contain both data and behavior. Data in a class are called its properties. Properties are data. Behavior in a class are called its method. Methods are behaviors. In non-OOP language, we call them functions. Object-oriented program is very good at representing in the real world. It's let us represent things like coffee, coffee cups, animals, peoples, and cars. With all that thing said, let's try to move up with a definition for what is OOP, object-oriented programming. So OOP is a style program that suggests you separate your code into classes. Classes are made of data properties and methods that describes what can be done to the data. So in OOP style programming, everything is organized into classes. There's no code that runs freely outside of class. Now, anytime we need to make changes to how coffee mugs work in our program, we make those changes to the coffee mug classes. All of the code is nicely self-contained in one place. Snapshot of our OOP class. So class coffee mug. Here you have property of the class data. So this is all going to be private. This is all going to be public. This is your constructor. And here your method of the class, since you have your void. So here, this is what your function is going to be. If and else. So here you have your if and else statement. If is false and if is true. So go ahead and key terms is class, constructor, object, instant. Anyone know how to say this word? Instantiate. There you go. Properties, methods. Lesson 6 OP. Go ahead and download that. Okay, let's talk about your C# programming class. About the C# program class. Okay, now with a little knowledge of class under our belts, let's revisit some things we've been pretending to ignore up until now. Every time we start a new C# console project, C# gives us this starting block of code. So here you have your default way when you open it. So C# have given us a class called program to start with. This class is intended to represent the software program itself. The program class has a method called main. So the main method is what is called the entry point of the program. This is where the programming always starts. Any code here in the main will run first. You should never create another class that has a method called main. So C# will become confused about which main method starts the program. So as you can see, we've been working in class by the whole time. By writing all of our code up until now in the main method, we're able to ignore objects and classes. So revisiting enums and structs, hopefully now it makes sense why in the previous lesson we had to put our enum and struct outside of main methods. Enums and structs represents data. So again, these are data types. They are data properties of the class, so we define them first within the class, then we use them inside the method. So again, start of the class, you have your enum, property of the class, and then here back down when you see a void, that means that you're going to start your method of class. A typical outline of a class. When writing a class, it's good to follow the structure of a typical class. You'll also typically write a class on its own .cs file. So class name, list of all the properties of the class. The class constructor, if it has one, it may not have one. List all the methods of the class, end of class. Let's go onto the let's go onto the Microsoft C# help website and look again at array list. Looking at the help documentation, you'll see it's a class, and the help documentation outlines the properties, methods, and constructs it has. It's a good idea to start looking at this help. So documentation, it should begin to start making sense. You might be able to follow it all, but knowing what you know, it should help you. It should start to seem helpful. So again, Microsoft wrote C#, and this is a good way just go ahead and follow their guidelines. Okay, so properties, here you have capacity, count, is fixed size, is read only, is synchronized, item, int32, sync root. So here you have your different properties. So count, yeah, that's a good one. Get the numbers of elements actually count containing an array list. And then here you could just mess around with like item int32 gets a set of elements in a specific index. Your methods, here you can have an adapter, creates an array list wrapper for specific I-list, add object, adds an object to the end of the array list, add range, add elements to I collection at the end of the array list. So let's talk about your class properties. In this lesson, we're going to practice creating some more classes while focusing on properties for these lessons. So in C#, let's create a new class. So in Visual Studio, click Project, Add Class. Name the class animal.cs. A new CS file will be created called animal. So here you're going to be using system.collection generic, and using system.text. So I'll just save this. And then I'll just type a new project. I could type a new file. Let it load. Look for C# class. Okay, so here we could just type in using system.collections.generic, using system.text, and it with a semicolon, and then we could just type in namespace lesson 600p, and then start with your argument. So in here we can put class animal, so I have this kind of closed down. Right. Boom. So we're just gonna name this animal.cs. Let's create some properties that our animal might have. For now, include the word private before each property we create. So give the animal legs. We'll make legs an integer to count the number of legs it has. Give the animal arms. We'll make arms an integer to count the number of arms it has. Give the animal a type such as an insect, spider, or dog. We'll make it a string. Give the animal a name. We'll make it a string. We want to know if the animal is dangerous, so let's give it a bool called is dangerous. Here's what the property of our animals class should look like. So in here, you'll just have your class animal. You'll have your private, enter your legs, get set, private int arms. So you can type this all in here. All right, so private int legs, get set, and then private int arms, again get set, and private string type get set. Okay, We'll talk more about private keywords and what get set do when we learn about encapsulation. For now, all you need to know is that they will help protect the animal from being messed with. Great. Now let's create a constructor so we can start creating animal objects. The constructor will need to know the number of legs and arms, the type of animal, the animal name, and if it's dangerous. Here's what our constructor would look like. So here you have your constructor here, public animal, and here you have your argument, and here you have your assignment of values. So don't get confused about arguments. We'll need to give the constructor 2 numbers, 2 strings, and a both so I can assign those values to the animal. We can name our arguments anything we want. These are the 2 versions of the constructor, work absolutely the same. Version 1 of the constructor. The arguments are named the same as the class properties. So here you have your public animal argument. Here your assignment values, assignment properties. And here everything's just public. Version 2 of the constructor. Now you have your fifth is dangerous is equal to value. The arguments are given a generic name and mapped to the properties. The results are identical. So this is also identical to, without having this.legs, you could just have that. So let's go see what. Okay, so what happened was he just put a bool to value, and then the value would be 5, so it would be here. Okay. The only difference is that you choose to name the arguments identical to the properties. You need to distinguish the class properties with the keyword this. The keyword this clarifies that you're talking about the property or method that belongs to this class and not some variable or argument that you gave the same name. Most programmers will tell you that the version 1 is better code because in version 2 we can mess up and assign the wrong value to the wrong property. Names like value 1 and value 2 don't mean much, so there's a greater chance for human error. Regardless of which way you create the constructor, we should be able to go to the main method in the program class and start creating them. So we created Snowball, a cat with 4 legs and 0 arms, Friendly with Spiral with 8 legs and 0 arms, Bobo, a monkey with 2 legs and 2 arms. So here you just have your value and set and so forth. So the cat is dangerous. Because let's go see why the cat, because it's true at the end. Lesson 6 OP. All right, so that's gonna be lesson 6. Let's talk about your class methods. Okay, so a method is simply a function that exists inside of a class. Before we can use methods, we have to create them. Let's look at the parts of a method. Number 1, a method takes no input and returns no output. So that's what a method is. It takes no input and returns no output. It's just a function. A method that returns the output but takes no input. So here, a method that returns the output but takes no input. So let me see why it takes that. So what is 2 plus 2? And 2 return 2 plus 2. Okay, so it's just executed by itself. A method that returns output and takes 2 input as input. This argument listed in the parentheses is that the value it takes as an input is also called a method signature. So list of arguments: input, name, data type, value type, console.writeLine, return number 1 and number 2. So you're gonna have to enter a number 1 and number 2 in here. So in object-oriented programming, we write methods to make our object perform actions. We also call these the behavioral object, which is a way of saying, what can I do with this object? For example, when using the console.writeLine a lot, console is a class and writeLine is a method in that class. It prints whatever we feed it to the screen, working with methods. Now let's keep working with our animal class and the program class and our main method to do this. On a new line, type animal1, autocomplete should kick in and show you all the properties and methods of the animal1 object has available to use. So here you have equal, get hash code, get type, and toString. You see there's not much there. That's because of 2 reasons. The first reason is we have not created any methods on the animal class. The second reason is that all of the properties are marked private. This means they won't show up and be available to use in the program class. Let's create a method to show the information about our animal. Get back to the animal class and create a method called show details. It will be a public method and returns nothing. Use the keyword void. It will print the animal's property to the console. Here's our show details method. So here you're gonna go down to public void show details, console.writeLine. So we're gonna concatenate name, type, arms, legs, and is dangerous. Now I'll go back to the program class main method and let's show the details some animals. Animal 1 dot show details, animal 3 dot show details. Here is just gonna type of your console. So he has one animal and one animal and another animal. Let's continue making some fun little methods of behavior for our animals. First, let's make our animals aren't dangerous. Create a method in the animal class called send to obedient school. It will return void. It won't require any arguments. If the animal is dangerous, it will no longer be dangerous. It will print animal.name is a good animal.type now. If the animal isn't dangerous, it will say but.animal isn't dangerous and do nothing else. Test the method by sending your animals to obedience school in the main method of your program. To view the solution, download the lesson OP project to your course. Create a method in the animal class called evolve. Evolve will accept 2 integers as arguments. Evolve will update the number of arms and legs to C to the new values. Evolve will change the animal type to say something else. So to view the solution, download this project right here on your project course. It should be in his Steve's GitHub. Okay, so let's talk about 6.5, passing by references, passing by values. So what happens to a variable when it's changed inside of a method function? So the answer is slightly confusing and can be difficult for new learners to nail down. We are going to walk you through the scenario step by step. So simple data types goes into method. Method spits out changes made inside method are applied to the copy. So here you just have your integer, strings, bool, data types. You have your pass by value, you have your method, and then so this is going to be changing what happens to a variable when it's changed inside of a method or function. Okay, so objects pass by reference. Any change you will make update me automatically, and it goes back. Changes are made inside the method are applied to the object. So here you have a passing by value. Static public integer add 3 int some numbers. Some number is equal to add 3 return some number. In our program class, we define a method called add 3. It takes some number as an argument in the method. It increases the number by 3 and it returns a result. Okay, so now in our main method, we'll use add 3. Static void main string args and my num is equal to 1. Add 3 my num console.writeLine my num. Recurring integer called my num with the value of 1. We can pass my num to add 3. The question is, what is the value of my num after it has been used by add 3? Is it still 1 or is it still 4? Alright, so it shows it right here that it's 1. If you guess the value is my num is 1, you would be right. Okay, so why is it still 1 and what happened? So when we fed my num to add 3 took what it was given and added 3 to it. Add 3 returned what was given. So the key to understand this is what the add 3 given. The answer is that it wasn't my num, it was given a copy of my num. So it changes the copy and the original value of my num has not been changed. We call this passing by the value to a method. When we pass by a value, we pass a copy of the value, not the original value itself. So to illustrate this, let's add more to our example. Okay, so you have my num is equal to 1. Insert a new number is equal to add 3. What was that? Plus 3 over there. And then you just console write line my num, and then you console write line the new number. Here we create a second variable called new number that equals whatever. Add 3 return. We see that indeed my new number is equal to 4 and my num is still 1. This is because new number holds the result of the copy. Lastly, if we want we can overwrite the old value of mynum with the copy returned by the add3 with this line of code. Here we explicitly write that mynum will be changed to equal to the result returned by the method. Static void main string args. Enter your mynum is equal to 1. My new number equals add 3. Mynum is equal to 3. Add 3. Console.write line mynum. Console.write line new number. Okay, the last question is, what did we want to do that made C# pass by value and create the copy? The answer is we didn't do anything special. C# just works this way when integers, strings, bools, date times, and other primitive data types. In general, if it's a simple data type, it is passed by the value. So example 2, passing by reference. Okay, so what is the other situation that can happen? The next situation is called passing by reference. And in general, this has always happened when an object is fed or passed to a method. Let's see our example. Let's create a class called SumClass. The only thing we'll add is a public integer called myNumber with a default value of 10. So SumClass, public integer myNumber equals 10. So here you have a class, and you have a public that's set to 10. Okay, we can do anything with that. Backend program, we'll create a method called add1. Add1 takes it in the SumClass object as an input, then messes with the myNumber property. So here you have a class program, static public int add3 into the int sum numbers. So here your sum number will be plus 3 right here. So here return sum number. Passing by the reference static public void add1 some class object to change dot myNumber plus or equal to 1. In our main method, we'll create a new instance of some class, so we won't work with it, and we will feed it to add1. So some class equals new some class add1 some class console.write line some class dot myNumber. So what is the value of some class dot myNumber after being used by add1? Is it 10 or 11? The answer is 11 because C# passes objects by reference. That means it doesn't create a copy technically. It's not exactly accurate to say it passes the object itself. It passes what we call a reference to the object, but their end result is the same. Rather than working with a copy of the objects there, we're updating the real thing through object reference. So at the end of this lesson, with a quick review of proper terminology, methods as mentioned before, is a method is just a fancy way of new word function, and a method can only exist inside of a class. Argument and input parameter that can be used as a method. Arguments are defined when creating a method. Calling a method when you execute a method. Passing to a method when you provide variables as an input to a method. My method passes to a value. And then you return. This is a keyword at the end of the method that returns any result that you want the method to return back. In C# we want to provide the keyword return as also lists what kind of data type is being returned when creating a method. You can't write any more lines of code after the return, so return should be the last line of method. So you could return multiple stuff, but usually that's going to be at the end of your code. So let's talk about your PowerPoints. Alright, so OOP versus procedural programming. So very much like a receipt for cooking. Procedural programming, what am I starting with? These are my inputs. What do I want to end up with? These are my output. What is each step in between to change what I started with into my final output? This is imperative. Procedural programming. Where do we most often see procedural? Operating system, scripting languages like JavaScript, PowerShell, older languages like C languages, embedded system, anything that is not a PC, laptop, desktop, tablet, or mobile phone, IoT. What are some of the challenges of procedural? Edge class, shared state, increased complexity as code gets larger, can be difficult to reuse, monolithic instead of modular. So procedural is just like a great foundation. Procedural programming, edge class, how I return books to library. Number 1, get in a car, drive to the library, drop off books, return home. How it returns books to library. If keys not found, search for keys. If car out of gas, add gas. If tire is flat, fix tire, get in the car. If accident on road, take alternate route, else drive to the library. Spaghetti code. Code that is difficult to read or understand. Code that jumps around a lot. Logic is not in one place. Shared state. So string my variable equals to 1. If my variable is actually 1, do this, else do something else. So here you have my variable, and then if it's 12, if it's 1, all this stuff into my variable that could be used. Complexity. Okay, now we're just talking about complexity. We have monolithic, microservice, monolithic versus microservices. Alternate, object-oriented. So here you have your object you're throwing out. Class bicycle. You have your public static, instant count. You have your brand, model, year. Your OOP, separate and organized code into smaller units called classes. Classes are like small, reusable mini programs, but they can be very powerful. Variables stored in classes are called properties, data. Functions stored in a class are called methods, behavior. Variables inside of a method are still just plain old variables. So we just kind of went over this right here. OOP approach to problem solving. What are the things that are part of the problem? Player, team, referee, football, end zone, anything that's related to football. And then here you're just gonna start throwing objects out like Tom, Brady, his speed, his number, his color, what team he's on, can you run past block. OOP can have all the same problems of procedural, can be monolithic, can be overly complex, can be crippled by shared state, can lead to spaghetti code. There's no magic bullet. OOP and procedural are both tools you should know. So that's gonna be about your OOP. Let's talk about your bonus lecture from Steve.
Hi, this is Steve, the Program Director for Web and App Development. And in this bonus lesson, we are going to be talking about object-oriented programming and procedural programming.
Give me a second.
And what they are and what are the...
Let me see if I actually went over this. Okay, yeah. So we don't have to go over this because I'm pretty sure this is just a PowerPoint of Steve going over the bonus lecture. All right, so that's gonna be it.